40 GB of dangling images and anonymous volumes silently ate your disk. Jenkins was creating new volumes for every build and never cleaning them up. Let's break down Jenkins Docker integration, how it works, and the exact mistake behind that failure. Jenkins Docker integration allows you to run pipeline steps inside Docker containers. Instead of relying on long-lived build agents, Jenkins spins up a container on demand, executes the build, and destroys it. This provides a clean, isolated environment for each build, eliminating the works on my machine problem and preventing resource leaks. Before Docker integration, Jenkins builds ran on static slaves that accumulated state, leftover files, outdated dependencies, and disk bloat. A build that passed on Monday could fail on Friday. With Docker, each build gets a pristine environment, eliminating these issues and dramatically reducing build failures. To set up Docker integration, install Docker on your Jenkins master and agents, add the Jenkins user to the Docker group, and install the Docker pipeline plugin. For declarative pipelines, use agent docker image node 14 alpine to run the entire pipeline inside a container. When writing Docker-based pipelines, always specify image tags, use always pull true to ensure fresh images, keep Docker files lean with multi-stage builds, and define the agent at the stage level to allow different environments for different stages. To build Docker images inside a pipeline, you typically mount the host's Docker socket. However, this is a security risk. Prefer using Docker build, which handles the build without needing the socket, and use Docker with registry for secure registry authentication. Secrets management is critical. Use Jenkins Credentials Binding plugin to inject sensitive values as environment variables or files into the container. Never hardcode passwords or tokens in your pipeline code or Docker files. To speed up Docker builds, use a local registry mirror or pull-through cache. Leverage layer caching with cache from. Use Docker ignore to reduce build context and pre-pull common images on agents. Disk exhaustion is the most common production issue. Implement a cleanup strategy. Run Docker system prune AF volumes via cron, add post-build cleanup steps, monitor disk usage with alerts, and consider a separate Docker file system. The agent Docker. Syntax shown in this article requires the Docker pipeline plugin version 1 or later. In earlier versions, the Docker keyword was not available in declarative pipelines. You had to use scripted pipelines with Docker image. Inside, verify your plugin version to avoid syntax errors. The article mentions Docker build, but doesn't show how to leverage layer caching with cache from. This snippet demonstrates building an image while reusing layers from a previous build to speed up subsequent runs. Mounting the Docker socket v/var/run/docker sock/var/run/docker. Sock gives the container root level access to the host Docker daemon. In production, restrict this to trusted pipelines only or use alternatives like Docker build, which uses Jenkins' own Docker client or rootless Docker to reduce risk. The article warns about cleanup race conditions. This snippet shows how to label volumes during a build and prune only those labels, avoiding removal of volumes still in use by other builds. When a Docker pipeline fails, check the console output for Docker error messages, reproduce the issue locally with Docker run, inspect the container by adding sh sleep 3600, and check Docker daemon logs. Hardening Docker agents is crucial. Run containers as non-root, drop all capabilities and add only needed ones, set memory and CPU limits, and scan images for vulnerabilities before use. For builds requiring multiple services, use Docker Compose within a pipeline. Ensure cleanup with Docker Compose -v and use unique project names per build to avoid conflicts. For complex orchestration, consider scripted pipelines. Monitor key metrics like Docker daemon health, image pull times, disk usage, and build failure rates. Use Prometheus with the Docker exporter and set up alerts for disk usage above 80% and other critical conditions. Migrating from static slaves to Docker agents requires careful planning. Audit your build environments, create Docker files, test locally, set up a private registry, and migrate jobs gradually, starting with non-critical ones. This is the same issue we highlighted at the start. Here's exactly why that happened. Jenkins was using Docker run v to mount temporary volumes for workspace data, but these volumes were never removed after the container exited. Additionally, images pulled for different builds were not cleaned up, leaving dangling layers. Over time, this accumulated 40 GB of garbage, causing no space left on device errors. The cron job used Docker system prune-af without the volumes flag, so anonymous volumes accumulated and caused disk exhaustion. Adding volumes ensures volumes are also pruned. The fix was to implement automated cleanup. We added a cron job that runs Docker system prune-af volumes daily, configured a Jenkins Docker cleanup plugin to remove unused resources after each build, and added monitoring to alert us when disk usage exceeds 80%. The key was including the volumes flag to remove anonymous volumes. Using the latest tag can cause builds that worked yesterday to fail today because a newer version introduced breaking changes. Always pin images to specific, immutable version tags like node 14 alpine. A common mistake is assuming Docker's default cleanup will keep your disk clean. Without explicit cleanup, dangling images and anonymous volumes accumulate, leading to disk exhaustion. Always set up automated cleanup with Docker system prune-af volumes. Mounting the Docker socket gives the container full access to the host Docker daemon. A compromised pipeline could delete critical data or launch malicious containers. Restrict socket access or use Docker build instead. To debug Docker pipeline failures, start by checking the Jenkins console output for error messages. Reproduce the issue locally by running the same Docker command manually. If needed, add sh sleep 3600 to keep the container alive for inspection. Also check Docker daemon logs with journal.u Docker. Let's run through some common interview questions. How do you run a Jenkins pipeline inside a Docker container? Use agent Docker image. In declarative pipeline, what is the difference between agent Docker and Docker image? Inside, agent is declarative for whole stage, inside is scripted for granular control. How would you build a Docker image inside a Jenkins pipeline without mounting the Docker socket? Use Docker build or Kaneko. And a few frequently asked questions. Can I run Docker commands inside a Docker container in Jenkins? Yes, by mounting the Docker socket or using Docker build. How do I pass environment variables to a Docker container in Jenkins? Use the args parameter with e or with env. What if the Docker image is not found? Check the image name and tag and ensure the registry is accessible. To recap, use Docker agents to ensure isolated, reproducible build environments. Always pin Docker image tags to avoid unexpected breakage. Automate cleanup of dangling images and volumes to prevent disk exhaustion. Use Jenkins credentials binding for secrets and monitor Docker daemon health and disk usage with alerts. Ready to go deeper? Up next, Jenkins Kubernetes deployment, then Jenkins Sonar Quebec quality gates, then Jenkins credentials and secrets management. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.